So first of all, I want to thank Marcelo for keeping me focused on complex systems information and the interaction of complex systems emergent information with notions of the canonical theories of quantum and classic statistical mechanics. And then I want to thank David for repeatedly reminding me of the concept of non-ergodicity and how deep it is. And then I want to thank Richard for reminding me to carefully understand statistical mechanics. So anyway, without all of those three people influencing me, I wouldn't have been nudged this way and that way to kind of come up with this rather simple thesis. So I'm going to summarize the thesis right now, and then I'm just going to take you through my verbatim PowerPoint presentation. So the thesis is this: classic and quantum statistical mechanics is a theory based on the notion that at the very core of reality, randomness is the fundamental stuff of nature. And so what we have is an ergodic theory wherein the microstate configurations that are energetically equal and describe some macroscopic configuration with a fixed energy E are all equally probable. But if it were possible that emergent forms of ultra-high complex information can act in a force-like manner upon the statistics, acting as a statistical force, then in principle, that very difficult to compute and even difficult to characterize emergent complex systems information can act as an ergodicity buster to dehomogenize the microstate configurations in order to select for the ones that lead to higher magnitudes of emergent complex information according to whatever the strategy is of that system of complex information. Because complex information and the choices of which complex information to do get very complicated as you get into DNA and its objectives to do this or that, or a human being and their objectives to do this or that in creating meaning or notions of hard to pin down complexity. So that's the basic thesis, and then I'm going to go into kind of a whole buildup of that. So I'll share screen now. It's called bending the second law. And what that means is we're bending the ergodic distribution of microstate probabilities into a dehomogenized set of probabilities. And that is not at all what the quantum and classic ergodic second law allows. So the importance of the second law. So the second law in both its classic and quantum form is very important and foundational because it's about our reality. It's about how our reality moves and changes. So it's about the flow of transformations in nature, many transformations, including particle coordinate transforms, kinetic to light energy transforms, exchanges of electrons that transform atoms. And these are just to name a few of the many flows and transformations. So in general, these flows and transformations of energy behave collectively in a fluidic manner, such that all of reality can be seen as a complex evolutionary flow of base information. So what is our motivation to revisit the quantum statistical second law? So our aim is to go beyond the base or letter level information of qubits in order to articulate how emergent information is key to fundamental physics. Our paper, which was published in the journal Entropy, says emergent information in a complex system is statistically causal on all parts of the system in a force-like manner, as with the notion of entropic force or Tonini's notion of complex systems information influencing the behavior of the system. So think carefully about that statement. All forces of nature are supposed to be described by some quantum gravity theory. So is the emergent information that in some cases is based on free will and can act in a force-like manner going to be part of a letter level quantum gravity model that deals with just qubits? If the answer to that question were no, then it means that a qubit-only quantum gravity theory would be incomplete. Axiomatically, the second law in all of its general formulations is an ergodic family of models. In other words, all microstate ensembles of the state space that define some macrostate at a given energy are equally probable. Accordingly, we can simplify S equals K log W to just S equals W and see that entropy is the quantity of microstates corresponding to a given macrostate. So the more microstates that give rise to a macrostate, the more probable that macrostate is, and the higher its entropy is, if reality is based on ergodic quantum stat mech. However, my thesis is this: quantum theory and stat mech ignore emergent information and do not deal with the notion of high EP and EC as a force-like quantity. Accordingly, I believe that in special cases, such as with the abstraction of the four-letter code-based high EP of DNA, or with a human mind, ultra-high emergent information acts back upon the ordinary ergodic spread of microstate configurations to alter their probability ranks from uniform to non-uniform. Specifically, I'm hypothesizing that emergent information leads to a non-ergodic quantum and statistical mechanics, and where, in almost all cases, the ergodic form rules as the best approximation of nature, the normal form. Because quantum and classic thermodynamics do not account for this greater than base level information that influences the evolution of systems, we cannot presume the second law to be true unless we are positive that this unaccounted for information does not ever bend or dehomogenize the ordinary ergodic statistics. This is not a discussion about the never statement of the second law as it was articulated by Carnot and Clausius, which measures the amount of heat lost when energy is transformed into work and where heat loss equals disorder. This is about the almost never statement captured in Boltzmann's statistical formalism, which is a more general entropy as a measure of the number of possible microstates that lead to a macrostate. So each microstate is described by a vector of position and velocity with microstate values, energy, volume, and the number of particles, where the only microstates that are disallowed are the ones that are not equal to the system energy E. And this leads to the idea that any system in equilibrium is equally likely to be in any one of these accessible microstates. Or we can say that if there are n microstates with energy E, the system has a probability of 1 over n to be in any of the microstates, as long as the macroscopic system energy is fixed. A probability function describes the likelihood that an entity will be in a particular state. Generally, in stat mech, the systems are understood to be large collections of identical particles. A microstate is a quantity of particles in each energy state. And then a macrostate is a quantity of particles in each of the energy levels of the system. For example, let's say we have 4 particles, A, B, C, and D. There are, let's say, 2 particle energy states that we're allowing, and our microstate allows there to be 2 particles in state 1 and 2 particles in state 2 for a total of 6 possible microstate configurations to describe this macrostate.
I just wanted to say that it's a little more complex than that, but I don't want to break it up. So yeah, feel free to keep going.
Okay. So then simplifying S equals K log W, we can say that entropy is the quantity of microstates corresponding to a macrostate, and the more microstates that give rise to a macrostate, the more probable that particular macrostate is. So high entropy equals more probable macrostate. So in an isolated system, the system will tend to progress to the more probable macrostate. The new view about the second law can be simplified thusly. Boltzmann statistics are for ordinary systems, devoid of special cases of EPN greater than 1, where the special case means they are very high EP and they're very unusual in how they encode information that leads, to growth of complexity. So these are special cases. So Boltzmann statistics, therefore, are for the ordinary world that we typically see around us in the universe, which are, by observation, mostly systems devoid of very high EP or EC information, capable of bending canonical, classic, and quantum ergodic entropy theory probabilities into non-ergodic spreads. So a human is an example of an EP n greater than 1 to EC informational system that, quote unquote, artificially steers the statistics of ordinary nature in a manner that is not prescribed by any physical theory. Schrödinger shared a similar view when he said, "My body functions as a pure mechanism according to the laws of nature. Yet I know I am directing its motions. I control the motions of the atoms." And he discusses how consciousness, he was focused in that section on consciousness. So he discusses how consciousness steers macroscopic statistics, which in turn steers microscopic statistics. And he was trying to reconcile this, right, in his mind with quantum mechanics as he understood it and with statistical mechanics. So later, I will refer to the ability of consciousness or high intelligence-like forms of EP, such as DNA, to bend ordinary statistics as macroscopic Maxwell's demons. My view of the essence of the demon is that it is an entity that messes up ordinary statistics because it has intelligence and free will that enable it to do so, right? If you remember the demon in Maxwell's experiment, the guy was devious. It was just this little demon who had the intention of messing up, right? The classic statistics, right? So is DNA intelligent, right? Because a Maxwell's demon has to be intelligent. So is DNA intelligent? So I can't answer that question because intelligence is a blurry concept. But what I do know is that, like our minds, DNA seems to be a dynamic and never repeating expression of syntactical language freedom. So if you study modern realizations of how gene expression works in relation to thoughts, emotions, and past collective experiences, and the tendency of biomes to complexify or survive over time, it appears that DNA itself encodes and directs a 4.6 billion year self-evolution of Earth's biosphere. So DNA has some form of free will and some form of intelligence that are very hard to pin down. But where do we conceptually cut this system of DNA off? That's this, because DNA, your DNA encodes the entire 4.6 billion year evolution of life on the planet. It's not just encoding your characteristics alone. Because DNA interacts with a super system. It interacts with a lot of other systems and forms a super system that you don't know where to cut it off. So it interacts with the weather system, the sun and its energy, gravitational pulls of the moon, thermal energy coming from the core of the planet, and so on. So I will refer to DNA as a microscopic Maxwell's Demon or an ergodicity buster. I have previously written about how consciousness requires free will, because to think is to choose what to be aware of. It's to create your own concatenations of ideas, right? Where how you concatenate the ideas forms emergent hierarchical idea structures. That is the very definition of your notion of consciousness. In other words, if you are aware only of the things that somebody else makes you aware of, then you are a reflection of their consciousness, just a copy. So you have to be able to be a unique consciousness. You have to be able to non-predictively or in a free will sense choose how to create your networks of meaning and thought or awareness. And it seems to me that thought itself has a hierarchical or emergent symbolic structure. And the paradigm of QGR is language theory, but particularly the hierarchical notion of language theory. We claim that consciousness and physicality are emergent manifestations of a base level mathematical language that is caught in an evolving transtemporal strange loop that spins out higher order symbolic languages such as DNA and human thought. A quintessential feature of language is syntactical freedom, which makes its expressions non-deterministic. The emergent intelligence of our biosphere is most profoundly encoded in DNA, which encodes your capacity for consciousness. So there's a deep relationship, in other words, between DNA and your consciousness, since DNA encodes the capacity for your consciousness. So the emergent information of your body-mind system, including free will decisions of what to think, end up looping back to influence the syntactical expression of the DNA code itself in real time in well-known gene expression experiments. So your DNA is constantly modifying itself, not just with random mutations provoked by neutrino collisions, right? Your DNA is constantly updating its code in well-known gene expression actions based on every thought, emotion, decision, environmental influence that you have. It constantly alters itself. For example, your choices of belief and emotional experience act upon gene expression or syntactical rearrangements of your DNA. With that said, let us see what Schrödinger had to say about this microscopic Maxwell's Demon, DNA. Statistical mechanics has a lot to do with the natural tendency of things to go over into disorder, but to reconcile the high durability of the hereditary substance, which was DNA, with its minute size, we had to evade the tendency to disorder by inventing the molecule. In fact, an unusually large molecule, so this is before DNA was discovered. So inventing the molecule was his hypothesis of what the molecule would be like. So it had to be very, very large, he speculated. And it has to be a masterpiece of highly differentiated order, safeguarded by the conjuring rod of quantum theory. The laws of chance are not invalidated by this DNA, but their outcomes are modified. This is what I call statistical bending. So he's saying it doesn't render the system to be deterministic, and it still allows it to be based on probability theory, but the outcomes or the probabilities are modified. And that's what reminds me of this conjecture that complex systems information can loop back to dehomogenize the ergodic spread of probabilities that we talked about earlier. And Schrödinger continues to say the physicist is familiar with the fact that the classical laws of physics are modified by quantum theory. There are many, in other words, the statistics are different, slightly different between quantum theory and classic theory. So one modifies the others. And so he says, there are many instances of this ability to modify statistics, and it seems that life, right, is one of them, a particularly striking one. So he views DNA as this thing that can modify statistics. So thanks to the synchronicity of David repeating the term non-ergodic several times, and also my intuition to pay attention to what David was saying, I am able to speculate that Schrödinger's somewhat blurry words in 1949 can be recast in this way. The ergodic quantum stat formalism can be modified by a new non-ergodic quantum theory. The emergent information of the DNA code is a striking example of modification of ergodic quantum theory into a non-ergodic one because the quantum formalism has no role for language theoretic emergent information as a statistical force or modifier of probabilities. Not in its current form or in its computable forms, which I'm going to get into later as I talk about a hierarchy of wave functions, where, for example, there is an extremely high level of wave function that describes Marcello. So if you put wave functions in a hierarchical structure, the wave function that would describe Marcello would be ridiculously and exponentially non-computable with today's technology, but yet it would exist. And that wave function is at a lower rank than the wave function that describes Marcello and David, right? So the resonance, quantum resonance, quantum dissonance, and the complex information that emerges from the combination of David's wave function and Marcello's wave function. So although this is completely non-computable, since we cannot even use quantum mechanics proper to calculate the wave function of a calcium atom, right? We know that this is very, very difficult to compute, but we also know that in principle, these emergent strata of complex wave function combinatorics must be real if we are to take the quantum theory seriously. So there are a small number of refereed experimental papers that show the almost never prediction of the second law can sometimes be bent to almost always, but they're very special cases. And these cases only occur with intelligence or high-level emergent information being involved in one way or another. As mentioned, this statistics bending emergent information can take the form of microscopic or macroscopic, quote unquote, Maxwell's demons. A microscopic case is the 150 zettabytes of information in the human genome that took 4.6 billion years to encode or learn. Schrödinger believed that the gene of life was what he called an aperiodic crystal, something that we might call today a quasi-crystal. His deduction of the atomic motif was based on his belief that overly simple crystals and overly random amorphous materials could not encode this tremendous magnitude of emergent information that instructs disorder or entropy how to increase or decrease. Of course, today we know that DNA is a quasi-periodic crystal with H3 icosahedral subgroups and H2 symmetry along its axis. Schrödinger believed that life was able to reduce entropy locally according to how the aperiodic crystal provided energy manipulating instructions to pull low, note the word low, entropy from the environment to compactify it as the low entropy local disorder that he called self-organization. So he took a whole section of his book to explain how entropy correlates to a specific non-subjective form of disorder or randomness. He frequently interchanged words like organized with negative entropy. Now, Prigogine inverted part of Schrödinger's model by saying that instead of life taking low entropy from the environment and converting it to low local entropy, it takes high entropy from the environment and converts it to local low entropy or disorder, or order, I mean. Now notice that Schrödinger was grappling with consciousness because he was one of the founders of the deeper theory of quantum mechanics. But notice that Prigogine, on the other hand, spent the better part of his career on this one problem. So he went further in a sense. As a chemist, though, Prigogine was not as deep or fundamental as Schrödinger. In other words, he wasn't as willing to overturn cherished models as Schrödinger was, because Schrödinger was much more in the revolution of quantum mechanics that changed the world. Now, neither of these two brilliant men completed the picture. As a chemist, Prigogine, more than Schrödinger, was probably more committed to the dogma or the passion encapsulated in the quotes that I'm going to read you below about the sacredness of the second law. Schrödinger's book left more doors open by specifically saying that there is some deep fundamental future theory that will later explain how consciousness can modify statistics. But what might be the key concept that both men missed? Language theory. Examples of a macroscopic Maxwell's demon include humans, scientists doing experiments that violate the second law of statistics because they can repeat it by free will over and over to bend probabilities to make something that the statistical second law predicts will occur by natural self-organization with nearly zero probability into something that occurs with almost 100% probability. So just as billions of years of biospheric complex systems intelligence or strategy get stored in the abstraction of high EP DNA, a human, as a Maxwell's demon, extends beyond a single person into the abstraction of the entire collective process of science and technology. Perhaps it's the highest level form of EP plus EC that we know of so far. So what is the scope then of the second law? The second law needs to be taken down a notch, but only a tiny notch, where it can be freely applied to the vast majority of systems where it belongs, as opposed to every single special case in nature. So where does the second law currently apply at this stage of the increasingly complex evolution of our universe? Well, it seems to apply to almost all of reality. We have pointed our radio telescopes to countless regions of space-time, and we see nothing but inert matter in the universe so far. Virtually 100% of the mass energy of our planet is non-living inert systems. These are systems that do not loop back with ultra-high forms of emergent information to provide anomalous instructions to tell matter and energy how to evolve via modifying or bending the ergodic statistics into non-ergodic forms. As we know, human irrationality is inevitable in science. At times, it can be powerful and serve as a roadblock to critical thinking and creative advancement. Here are a few examples of highly charged and overly impassioned statements that are anathema to the purity of the scientific method. You've all heard this one. The law that entropy always increases holds, I think, the supreme position among the laws of nature. If someone points out to you that your pet theory of the universe is in disagreement with Maxwell's equations, then so much the worse for Maxwell's equations. But if your theory is found to be against the second law of thermodynamics, I can give you no hope. There is nothing for it to collapse in deepest humiliation. Pretty impassioned, right? So that was Arthur Eddington. Classical thermodynamics is the only physical theory of universal content which I am convinced will never be overthrown. Passionate, Einstein. So the second law is one of the closest things to being sacred in the minds of many scientists. And for good reason. I'm not criticizing that, by the way, because I understand their logic and their deductive process. But the very definition of a revolution in physics is the dethroning of logical theories passionately held to be true by predecessors. And we must keep in mind that entropy cannot be measured directly, not as directly as so many other things in nature. And accordingly, certain claims, both my claims and other claims, so claims both for and against the sacredness of the second law, these are all just informed conjectures versus strong empirical statements. And proving, and another thing to keep in mind, is that proving that something virtually never happens requires showing all special case experiments. So kind of impossible, right? While disproving that statement that something virtually never happens requires only one anomalous experiment to be rigorous and repeatable, right? So from 1990 to 2014, there have been 25 what I would call high quality scientific papers or challenges to the second law, and 70 refereed articles in these prestigious journals. And then from 2014 to 2020, the quality of the anomaly experiment papers probably improved. And since 2013, I believe, David has been collecting a best of mixtape of second law anomaly experimental papers that caught his attention. Now, the essence of what I'm speculating is that quantum mechanics and stat mechanics are the behavior of ordinary nature, or what you can call natural nature, in terms of how often we see something like a four-letter emergent code that instructs mass and energy how to behave, or human consciousness for that matter. Well, we can say that these things are abnormal or even unnatural, statistically speaking. For example, the legal definition of natural versus artificial in FDA law goes like this. If a consciousness, like a human, uses science or technology to assemble H, C, and O into ascorbic acid, it is unnatural or artificial. But if we find it laying around in nature or in the environment already assembled as a molecule, then it is natural. So by way of comparison, if 99.99 followed by many zeros % of reality does not involve ultra-high emergent information modifying the ergodic statistics of ordinary reality, well then this is the scope of what I call canonical or letter level or qubit-focused quantum mechanics and quantum stat mechanics. So those canonical stats are absolutely fundamental to understanding a future non-ergodic extension that deals with modifications of the fundamental stats. So we have to be very respectful and in tune with the ergodic statistical theory in order to move beyond it, right? So I'm respecting it. Now think of the fundamental ergodic stats as a type of a type of ground state, right? I'm using that word ground state very liberally, wherein deviations from the ground state statistics almost never occur in the universe. At this stage, they almost never occur. So because consciousness and ultra-high forms of multi-billion-year intelligence like DNA or biospheres are infinitesimal, are, as far as we can see, are an infinitesimal fraction of the current evolutionary stage of the universe. New physics dealing with how the ground state stats are modified from the ergodic to the non-ergodic special case form is crucial as a next step to bring the self-simulation hypothesis text and our earlier work like the code theoretic axiom and the PEL, like to bring that work into the realm of physically realistic formalisms for us later, you know, understanding this deep connection between the ergodic busters and the ground state ergodic stats is important. This is just a diagram to show that if the blue sphere is the universe and the orange dot is the percentage of the universe that goes non-ergodic, you can see, you know, how powerful and applicable and large the scope of the qubit-based non-emergent information quantum stat mechanics should be. And of course, this picture doesn't give justice to the scale. I mean, we're talking about exponentially smaller orange dot here if it was accurate. So Schrödinger wrote, living matter will not, right, while not alluding to the laws of physics as established up to date, is likely to, so he's saying that living matter is not easy to, or he's speculating that living matter is not modelable by the quantum formalism as he understood it. And so living matter, while not alluding to the laws of physics as established up to date, is likely to involve other laws of physics hitherto unknown. So unknown new physics, which, however, once they have been discovered or revealed, will form just as integral a part of science as the current quantum mechanics or current quant mech stats, to paraphrase. That's what I believe. So the new physics Schrödinger is speaking of is essentially biocentric centered or intelligence-focused physics. Now, this biocentric physics in 1949 was a joke, and yet he wrote about it. You know, he was struggling with this deduction. Biocentric physics barely existed as an academic, you know, level category. But that's changed. It's a little more respectable today. For example, a recent, within the last year, right, Scientific American article reviews these advancements beginning with this sentence. Now, Scientific American is just a popular, you know, science magazine, but they also have, their whole board of directors is set with PhDs, and all of their writers, you know, they try to stay credible, and they are basically reporting, they digest what the high level peer review advancement is doing, right, for lay people. So they're not really a new agey or controversial establishment. So the point, that's why I brought them up. So what they said in this article that's recent, they said that there have been a number of recent scientific papers, some of which are listed in the references section below, that have addressed the concept of a living universe, an intelligent living universe. So these papers are now showing up in academic circles. And then the Scientific American article goes on to say, this concept envisions spatiotemporal interactions between life and environment and how they modify each other. But again, they're going beyond just life on Earth to something deeper. So it is a systematic relationship that takes place through loops and feedback mechanisms. And it's these resonant feedback mechanisms that I'm going to get into later to describe a proposed mechanism of action between the quantum resonance and quantum dissonance, or the interference qualities between the wave function of Marcello and the wave function of David, and any other two or more complex wave functions. So I believe that QGR's approach is going to make an important contribution for two reasons. The first is that we're saying language theory is foundational. Now, this is similar, by the way, to language theory. For me always means hierarchical concepts, right? So this is similar to Wolfram's emergentist simple programs approach. And it's also similar to the approach of the semiotics community and the cellular automata communities like Gerard T. Hooft and others. But the second reason is a little more novel to QGR. The second reason is because QGR is starting with a syntax system derived via projective transformations of higher dimensional algebraic root lattices that are already known to correspond to string theory and the standard model. This is our I level of information, our base level letters that we start with. And from there, we go to a simple program-based language where EP1 becomes the letters, right, of fundamental particles in our program level just above the mathematical pre-physical level of little I. So, and we hope that this language-based hierarchy of EP1 to high EP and on up through EC will describe at an early level, right? Early levels of EP1, EP2, EP3. We hope these early levels will approximate the canonical ergodic quantum stat mechanics and basically an ergodic quantum gravity theory at the end of the day. But then upwards, our model of hierarchical structure looping back in transtemporal wave interference will describe how ultra-high EP and EC can act back on simpler systems to modify the ergodic stats to the non-ergodic stats in what is currently very, very rare cases as a total percentage of the self-organization of the universe at this stage. So here are some deeper thoughts about information and measurement. You know, a lot of the aspects of information and measurement is about the information we do not know. You know, we've got this idea of microstates, and we've got this idea of an even spread of EP1 probabilities that go to more noise or disorder or randomness, which goes to more micro configurations to describe a given macrostate, which goes to a more even distribution of system energy. But when you think about that, the computational energy or the mental energy to choose what to exclude, right? Like in other words, if I tell David there's a thousand flavors of ice cream and you can choose any one of them, right? His instructions going into that with complete freedom, no memory, no algorithm to be restricted on what he can choose. That kind of requires less information in David's consciousness, because David could just run into the 1,000 flavors and just choose anything without having to hold an algorithm of what he can't choose. But if I tell David, I'm sorry, David, you have 1,000 things, you know, here that I'm going to have you go in and look at, but I need you to be aware that you cannot choose number 137, number 732, choice number 436, and so on. The more of the restrictions that I tell him that he cannot choose, it's as though he has more of a load of complex information or a higher level of mind space that he has to allocate to remember what he can't choose. So it's as though there's less computational load in a consciousness sense required when there's less restriction. You can just do whatever. You can do more choices. So I'm really interested in cross-strata feedback loops using interference as a principle between various strata of high EP and IC systems. And I think this idea is key for the notions of our non-ergodic quantum stat viewpoint. So we have a base letter level of information as a graph state selection called an inflation. And we call this stratum of conserved information little I to represent a primordial form of base information. And this information is what we call pre-physical. Physical level information exists only as relationships of the pre-physical base information little I. So in the physical information hierarchy, we have an ordering of little I called EP1, right? An early ordering called EP1, and that represents our fundamental particles, which are quasi-particles. So in physical information theoretic terms, right, as opposed to pre-physical, EP1 is our qubit, right? So EP1 is our fundamental particle. So there can be more than one type of EP1, such as an electron or a photon. Now, EP1 elements have states called ISVs, or intrinsic state variables. But be careful, because that term intrinsic can be misleading if it provokes ontological ideas such as this is the state of the EP1 particle. Emergence theory is a probabilistic theory where consciousness interacts with the inert matter-based probabilities. For example, the ISV of an EP1 particle is a weighted statistical spread of probabilities for various orderings of I that are related to the energy level of that EP1 particle. So its probability spread is determined by the emergent information of its energy landscape, which is equivalent to the relational state variable information that it has with other EP1 systems, right? Or the whole system. For example, let's say that our universe is a system consisting of only two EP1 particles. The ISV probability spread of each one of the two is determined by its spread relative to the spread of the other particle and vice versa. Spread meaning the probability spread. So this relational information is called the RSV, or the relational state variable information of the system, and it also has a spread. So it's only an abstract probability spread, not a thing that is, right? The RSV itself, like I said, is a probability spread, which is analogous to a two-body wave function, or the random walk path integration of the two ISV packages of weighted probabilities. So speaking from the perspective of the enigmatic measurement problem, Wheeler said that we live in a participatory universe, where he is speaking of human consciousness as the participant with the deterministic probabilities of quantum mechanics. So about 11 years ago, before I understood much about quantum mechanics or the measurement problem, had never heard of the measurement problem, a verbal message dropped into my mind out of nowhere with syntax that was kind of unlike how I naturally speak. And it said this: all that exists is that which is seen. It was just so literal and verbal and not really feeling like my thought. Then later, I learned the essence of the Copenhagen interpretation as an ontology that divides things, right, into the, so ontology is about what is real and what is not real, right? So it's philosophy. This is real and that's not real. So you can see how ontology relates to physics, where physics is generally the idea of saying this is real about nature in my theory X, or this is real about nature in my theory Y. So the ontology of the Copenhagen interpretation of what is real and not real basically says that the unreal thing is the unitary evolution, where physicality means real. And the real collapsed wave function that is equivalent to a local manifestation of physical reality is the real thing in this duality or this binary idea of what is real and what is not. Now, the PEL indicates an ontology that is very similar to the Copenhagen interpretation, insofar as there being no motivation for the universe to simulate, compute, or actualize information that is not held in the mind of an entity that is capable of creating information. The PEL view is that the term information is meaning. So that's where we deviate. So PEL says meaning is something that needs to be defined by the inclusion of a notion of mind or consciousness. Meaning is something that exists when there is an entity capable of ascribing meaning and then choosing to ascribe that meaning. The Copenhagen philosophy of the quantum formalism is basically materialist. So it's a materialist ontology that says information becomes physical or real when a consciousness observes it into reality, right? Where it becomes a particle or a group of particles. The emergence theory interpretation of this aspect of quantum mechanics is a certain form of idealist ontology, which says particles exist within the mind space of a consciousness-only universe, which can include the mind space of yourself, since you exist within the mind space of the consciousness-only universe. In other words, there is not the same duality like in Copenhagen, wherein there is the real stuff and, or I should say that in other words, our duality says that the real and the unreal is the information that could exist if a consciousness chose to think about it or observe it, right? And that's not real because it doesn't exist, because a consciousness has to actualize it to exist. And then there is the information that does exist because a consciousness actualized it, right? So we have a dualism, and it says there is information which could exist if thought of, so it's not real, and information that is thought of, so is real. Pretty simple. Thoughts occur at various scales, such as a human, or the collective consciousness that is the universe. Maybe my dogs have thoughts. And because humans cannot observe at the Planck volume or time to create ultra-fine-grained physical meaning, measurements of ISVs and RSVs are a mere lensing of the probability spreads to various degrees of lensing, depending on whether we are working with, for example, an electron microscope, an attosecond laser, or a human eye. Measurements or observations in this context are about making decisions of consciousness about what and when something is not. So I'll explain. For example, we can say that a particle did not hit the screen in this region over here and in this region over there. Now this reduces our guess of where it did hit the screen to some smaller or lensed area. Our thoughts about the approximate location of the particle in space and time are not by any means EP information. They're not EP1 information. They are high level. I mean, they're not EP information at all, for that matter. Your opinion about the particle hit the screen in this vast constellation of Planck times and Planck volumes in this area because you believe that it didn't hit the screen in these other vast areas is an abstraction high up in the EC regime of your consciousness. You are not creating exactly or perceiving real EP information. You're perceiving EC. The emergence theory framework says the universe changes the ISVs and RSVs of the system around it to comport with the EC thought. So the emergence theory philosophy says that if Fong is observing the screen in a double slit experiment and she is deciding to create the EC information that a particle did not appear in most areas of the screen and therefore appears somewhere in these vast Planck scale regions that are left, that the collective consciousness as the sort of game substrate tries to comport or dance with Fong and her EC creation by modifying the statistics of the RSVs and ISVs that were involved, especially locally to Fong. All right, so these are very coarse-grained approximation thought, leaving the universe with, in other words, Fong's observation of the screen is very, very coarse-grained until she can develop technology that allows her to peer down at the Planck time and the Planck volume, right? She is left with EC creations that are very, very coarse-grained, many orders of magnitude away from the precision of the Planck scale. And that's good news for the universe because it allows the universe to enjoy Fong's high EC opinions of the measurement that she just created and leaving the universe a massively high degree of EP1 based microstate configurations that will describe that same macroscopic observational experience and creation of high level EC that Fong created. So you can see an entropic, you can see a StatMex concept at play there where the degrees of freedom of microstates of EP, of RSVs that the universe has to choose from based on Fong's observation is very large, and she makes it smaller based on how fine-grained her resolution over time or space is. So again, our physical measurements exist within the upper atmosphere of high EC in your minds. Our thought of a particle hitting a screen in approximately this area is not at all EP1 level information. And even looking at the fuzzy representation of an electron microscope image, okay, is information in our experience of high EC mind space. It is far from the actual little I or actual EP1 level of abstraction. So why would we live in a universe where self-emergent information can act like a Maxwell's demon that transforms ergodic microstate configuration sets into non-ergodic probability spreads? Well, here's the easy answer. Because the self-simulation hypothesis is true, along with its implications. And part of that is the principle of efficient language. The universe is striving for higher forms of information in order to more thoroughly create itself. We don't live in a world governed by meaningless randomness, where consciousness happened to emerge as a mere epiphenomenon, right, and is secondary to fundamental physics. Instead, we live in a universe with a direction of time called evolution of mind and evolution of general complexity or complex systems information. All right, like I said, that was easy to say as an axiomatic statement. But what is the mechanism of action that explains this shift to non-ergodicity in special cases? Intelligence as a Maxwell's demon, right? The way I'm using Maxwell's demon as a metaphor, is made of pure secondary or abstract emergent information. And so it is not at all like the thought experiment of Maxwell, where the demon is an inserted system using its own energy to think about the hot and the cold molecules and to take actions to segregate them, right? Humans use emergent information. Humans are emergent. So including their minds, these things emerge from the system. Like imagine a Maxwell's demon that just emerges from the system using the system's energy, not changing the system until it uses its emergent free will to do it, but it's part of the system. So anyway, Humans use emergent information, including their minds, to influence the statistical behavior of matter. And there is evidence that DNA does anomalous things. There's a couple good papers. One of the ways that they do this is to select. So this is where we're getting down to the end of the presentation. So one of the ways that this emergent information selects for high potential of even higher emergent information, or a metastability state of that emergent information, is that when there are two or more equally energetic microstates, that the thesis is that the emergent information is allowed to influence by inserting its preference for one equally energetic microstate over another, to prefer the ones that offer the most potential for more emergent information in order to fulfill the PEL axiom. So how would an emergent intelligence like DNA or a human know that one microstate is preferred for higher information creation than another, with this supposed this supposed ergodicity busting quality of emergent information? Like, how would it know? Well, think about it. If it were true that a wave function of a particle living in the present moment can be retrocausally influenced by the wave function of a particle living in the future, then it is true that complex systems, many-body wave functions, can retrocausally influence one another. Or you can say that the whole thing is a complex wave function that has retrocausal qualities, right? Like a feedback loop. So the future state of a system's evolution would then act as a strange attractor on the past system to dehomogenize its ergodic array of equal energy microstate configuration probabilities into a non-ergodic array, because of this feedback or Fourier type information between the complex system at time 1 and the complex system at some time 2. However, we can leave things not so mystical and not even get into ideas like consciousness. And we can also ignore the idea that reality works with complex systems, wave functions that influence one another retrocausally. Instead, just consider an EPN hierarchy that is made of wave functions, so that the wave functions are the hierarchy, a hierarchy of wave functions, right? The wave function of David over some duration would be a higher order complex information wave function than the wave function of a pebble. David is part of an even higher order wave function with himself and Fang. The wave function system exists in an emergent hierarchy of complex systems wave functions. And if such formalism would allow for them to be retrocausal or bidirectional in time, then the quantum formalism as it is would allow for an enormous amount of emergent quantum complex systems information. In other words, perhaps the quantum formalism, like Mia Hughes and others say, is already a retrocausal formalism. And we already know that the quantum formalism does, if you take it seriously enough, imply a universal wave function. And if that's controversial, it certainly implies a wave function for David. Now, could this unstudied and currently incalculable regime of emergent quantum information in the wave function formalism be responsible for the supposed possibility of high EP and EC to modify the ergodic statistics? Now, if so, it would work based on the mathematics of interference, specifically quantum resonance and quantum damping, of wave functions, like in the Lee et al. Paper, but with retrocausal ultra-complex wave functions. It would, in some sense, be, because of this notion of interference and resonance and dissonance, kind of be a musical universe based on interference, and where the music itself is non-periodic, but it's also very orderly music. Resonation between two systems mutually restricts each system and limits or dehomogenizes probabilities. So that's it.